Hello everyone, I welcome you all for today's session. So in this session we'll be taking up a numerical on analytical method. So I have written the statement for you. So let us start with today's video lecture. At a point in a strained material, the state of stress is as shown in the figure. So this is the figure which he has given us to have a look in the problem itself. Determine the principal stresses and orientations of principal stresses. So a very simple problem, right? Now let me start with the solution part directly. Now he has given this as 80. It also means that this is 80 Newton per mm square, right? When he has given this as 86.6, it means that this is also 86.6 Newton per mm square. So that is by default what you need to understand, right? So now let me start with the solution part of this solution part. So I'll write it as solution. So I am interested to find out what principal stresses and orientations of principal stresses, right? So principal stresses is given by sigma 1 comma 2 is equal to sigma x plus sigma y divided by 2. You need to know these formulas by heart. Under root of sigma x minus sigma y divided by 2 the whole square plus tau xy square, right? Now sigma 1 comma 2 will be equal to what? Sigma x plus sigma y. What is sigma x? 86.6 plus sigma y is 80. I am taking both positive because both are tensile in nature, right? Plus or minus under root of 86.6 minus 80 divided by 2 this whole square plus tau xy. Now for tau xy you should be careful. Why? Because I need to take the direction of tau xy depending upon the reference plane. So till now I have not decided which is my reference plane, right? In order to decide which is my reference plane, what I need to do? I need to draw an oblique plane such that this normal is making 30 degrees, right? So let me draw an oblique plane first. Let me draw the oblique plane. I draw the oblique plane here, right? I will draw the oblique plane here at some angle. Let us say this is the angle at which I am drawing the oblique plane, right? So this is the oblique plane what I have drawn, right? Now in order to decide the magnitude as well as direction, magnitude is fixed, it is 50, but whether I should take it as positive or negative, that depends upon which will be my reference plane. So I told you, if this is 30 degree, then automatically this angle will also be 30 degree. I have already explained in the previous video how I will take this angle as 30 degrees, right? So you can go through my previous video, that is first video, so that you will understand how this 30 degree and this 30 degree are correlated, right? Now this will be my reference plane. This will be my reference plane. This will be my reference plane, right? So I'll just denote this as 2 points. So I'll call it as B and C, right? So B and C. So if BC is the reference plane, with respect to BC, what is this direction? This 50, it is making anti-clockwise direction. With respect to this vertical plane BC, which is my reference plane, this 50 is making an anti-clockwise direction. So anti-clockwise is always negative according to our sign convention, right? So I'll write here it is minus 50 the whole square, right? In bracket I'll write here considering BC as reference plane, right? So this is important because in some textbooks you may take some other reference plane and you may take it as plus 50, right? So you should be very careful. So sigma 1 comma 2 will be equal to, so this will be equal to 86.6 plus 80 divided by 2, which is 83.3 plus or minus. So in this, let me check out what we'll be getting. 86.6 minus 80, so that is divided by 2, and I need to square this. Plus square root of a negative number is always positive, so 50 square and square root of the answer, so it is 50.10, right? So let me write sigma 1 and sigma 2. So sigma 1 is equal to and sigma 2 is equal to, right? So sigma 1 is how much? 83.3 plus 50.10, so it is 133.4 Newton per mm square, right? Next, sigma 2 is how much? 83.3 minus 50.10 minus 50.10. So let me check out how much we are getting. So it is 33.2. I'm getting the value as 33.2, right? So this value is 33.2 Newton per mm square. Okay, now once if this is done, right, now I'll go for the second step, which is I need to find out the orientation of principal stresses. So orientation of principal stress, the formula is given by, formula for orientation of principal stress is given by theta P1 is equal to 1 by 2 tan inverse 2 of tau xy divided by sigma x minus sigma y, right? So this is the formula which will give me the value of theta P1. So if I substitute the values, theta P1 will be equal to 1 by 2 tan inverse of, now here you be careful, tau xy is taken as negative according to me, so it is 2 into minus 50 divided by sigma x minus sigma y, both are tensile in nature. So sigma x is 86.6 minus 80, right? So let me check out what value of theta P1 I will be getting. I will be solving it here. So this side it is 50 into 2 is 100, so it is minus 100 divided by this value will be 6.6, right? So I'll be getting this value. I need to take tan inverse of that, right? So tan inverse of this will be shift tan inverse of answer, right? It will be 86.2 and I am having 1 by 2 outside, so I need to divide it by 2, so it is 43.11, right? So therefore theta P1 will be 43.11 degrees. Theta P2 will be theta P1 plus 90. Theta P1 plus 90. So I will be getting, this is with the negative sign, so that is sign is also important, please don't skip it, right? I will be getting the value as minus 43.11. So I need to add plus 90 to that. I'll be getting 46.88. 46.88. So that is 46.88 degrees, right? So this is positive. Right? So this is the orientation of theta p1, that is principal plane, which is major, and this is for minor. So these are the location or orientations of principal plane. So the only important thing is how you take this, and it depends upon what will be your reference plane. Right? So I hope things are clear. So that's it for today's session. Have a good day. Take care. Bye bye.